Okay, so this is section 3.3, and the title is Properties of Functions. Okay. Alright, so let's start. Again, this is in the pink study guide that I handed out in class, and we'll start with a definition. We're going to talk first about increasing, decreasing, and constant functions and how you can identify that. So let's start with a couple of definitions. A function f of x is increasing. Okay, so function f of x is increasing on an open interval if for any x1 and x2 in the interval where x1 is less than x2, then f of x1 is less than f of x2. So what does that mean? Okay, let's talk about what that means, because that definition can look kind of complicated. When I'm talking about an increasing function, let's go ahead and draw an xy plane. And here I'll change color for the picture. Let's grab blue. Okay, so if a function is increasing, then it means it is rising from left to right. So the way you would read a book is the way you would read a graph. So when I'm looking at this from left to right, the graph is rising. So I know that it is increasing. So where does this definition come from? Well, if I'm considering an interval on the x-axis, let's say this is x1, we'll say this is x2. Well, f of x1, right, is this length right here, because this point would be x1, f of x1. So f of x2 would be this length, because this point would be x2, f of x2. So this makes sense. If x1 is less than x2, then it would be to the left of it on the x-axis. And if the function is increasing, then look, this y value, or f of x2, would have to be larger than this y value, f of x1. So that's where that definition comes from. But when you're eyeballing a graph, really you just need to read the graph the way you would read a book. So if it's increasing from left to right. Okay, so jumping down to decreasing. So if a function is decreasing on an open interval, if any x1 and x2 in the open interval with x1, again, less than x2, then f of x1 is greater than f of x2. And again, as strange as that looks, it makes sense when you draw a picture. So again, let's get our xy plane going. And I'll change my color for the graph. Okay, so if it's decreasing, then it's falling from left to right. So this is a decreasing graph. And again, if x1 is smaller than x2, then it would be to the left of x2. And then you can see that those corresponding y values, x2 in this case would be smaller than f of x1. So actually that definition makes sense. Because again, then this length would be f of x1. And that's going to be higher, so greater than f of x2. Okay, so again, the easy way to think about it though is, again, you read a graph the way you read a book. If it's falling from left to right, then it's decreasing. Okay, so switch the page. So how do we know when a graph is constant? Oops, it's not writing very well. So constant in an open interval, if for any x1, x2 in the open interval, then the y values are equal. So f of x1 is equal to f of x2. So again, how is that reflected when we're looking at a graph? Well, if it's constant, then again, those y values will be the same. So again, if this is x1 and this is x2, then this would be x1 f of x1, and this would be x2 f of x2. So they would be actually the same value, which is why it's equal. So when a function is constant, we just see that flat straight line. Okay, so first example that we come to is on what open intervals is f of x equals x squared increasing. So we know what f of x equals x squared looks like. It is a parabola, and the origin is at 0, 0. So this is f of x equals x squared. Then when is this graph increasing? Well, it is rising from left to right, right here. And it's actually falling from left to right to the left of the y-axis. So if we're just identifying the interval where it is increasing, then we would start here, and this would go on to infinity. Now we always use an open interval because a graph isn't said to be either increasing or decreasing at any specific point. So we would say it's increasing on the open interval using the round parentheses from 0 to infinity. And if we were to say where it's decreasing, again, it's decreasing on this side because it is falling from left to right. So it is decreasing from negative infinity to 0. And since it is never flat, it's never constant. So it is either increasing or decreasing, but it is never constant. Okay, so going on to the next page, let's talk about maxima and minima. And to do that, let's draw a sketch. Let's draw a little picture. So we'll start with xy plane. Here's x and y. Okay, and then let's draw a picture. Okay, let's say that this is our f of x. Okay, well, this high right here would be considered a local max or a local maximum. And down here, we would say that this low is a local minimum, or just local min. So I think intuitively that makes sense. The reason is it's a local max if it is increasing on the left side and decreasing to the right. A local min is decreasing on the left and increasing on the right. So if we say, let's say this point is, let's say negative 3, 5, and maybe this point is 2, negative 4. Now, the language that we use is important, so it's important that you know how to say this, or when it's written, exactly what it means. We would say we have, remember this point is also known as negative 3 f of negative 3. So that means f of negative 3 is 5, and we talked about that in 3.2. So in terms of the local max, we would say the local max is, so the value of the function is the local max. The local max is f of negative 3 or 5, and it occurs at x equals negative 3. Should be about right there. So we would say the local max value, or the local max, is 5, and it occurs at x equals negative 3. So likewise, when we're talking about the local min, we would say the local min is negative 4, and it occurs at x equals 2. So it's important that when you're asked to find the maximum value, you're looking for the y-coordinate, or you may be asked, where does the local max occur? And then you would answer with that x value of the xy pair. So again, it's important that you understand the vocabulary. Okay, so last thing we'll talk about with this video is that last example, and it says, will f of x equals negative x squared have a max, a min, or neither? So remember from the lab what negative x squared looks like. It's that upside down parabola. So it looks like this. So will this have a local max, min, or neither? And why don't you go ahead and answer that one, and we can verify the answer in class. Okay, so I'm going to stop this video for now, and we'll continue section 3.3 with video 2.